Day 40, page 888, problem 37. This is supposed to be a chunk of ice. Once again, to have a critical angle, you need to be in the more dense going to the less dense, which we are in this case. It says air-ice interface. You have to be in the ice to get a critical angle because you cannot have one from air into ice. So if I draw my normal, you didn't have to draw the diagram for this one, but bottom line is, just to review, the definition of critical angle is that such that you're at the angle, this would be the critical angle here, theta sub c, such that if you had a refracted ray, the refracted ray would be at 90 degrees. In other words, theta sub 2 would be at 90. Well, that doesn't happen. You can't have a refracted angle, theta sub 2 cannot be 90. So I'm going to erase that. So what happens when you get there, at that exact moment when you have the situation when that theta sub 2 would be 90, you get total internal reflection. So the reflected angle will be equal to the critical angle. You have total internal reflection at that point. But bottom line, it follows from Snell's law, that is n sub 1 sine theta sub 1 equals n sub 2 sine theta sub 2, where theta sub 2, the refracted angle, would be 90. And the sine of 90, equals 1. So basically that falls out of the equation. So what you get, in the case where you set your theta 2 equal to 90, theta 1 then would be called the critical angle, or in other words, if you reduce this, you get the sine of the critical angle when theta sub 2 is 90 is the ratio of n sub 2 over n sub 1. So that's my version, or it's the critical angle formula. You can say theta sub c, the critical angle, is the inverse sine of n sub 2 over n sub 1. But bottom line is, we just need to plug in the index of refraction of the two substances, two mediums. N sub 2 here is air, so that's 1.00. And you have to look up ice. It's around 1.33, because water is 1.33, but ice is, I forget what ice is. Look that up. And then, so n sub 1 is the ice. Plug that number in and just do inverse sine to get the critical angle.